100 milligrams of a drug are to be given to a patient. At the end of the hour, the number of milligrams of the drug left in the body is 10% less than at the beginning of that hour. How many milligrams of the drug are left in the body at the end of 4 hours? So there's a long way and there is a short way to do this question. The question is asking us to reduce the amount every hour by 10%. So we're going to start with the long way. We are going to find 10%, then we are going to take it away from the amount that we started with. So to find 10% of 100, we divide 100 by 100, and then we multiply by 10, which is the percentage we want, and we get 10. We then take that 10 and take it away from 100, and we are left with 90. So this is how much we are left with after 1 hour. We are now going to repeat this process to find out how much is going to be left at the end of the second hour. So we find 10% of 90. We divide by 100, multiply by 10, and we get 9. We then take that away from what we started with, which was 90. So 90 take away 9 is 81. That's how much we have left at the end of the second hour. Again, repeating this, 81 divided by 100 times 10 equals to 8.1. We're going to take that away from 81 to find how much is left at the end of the third hour. So 81 take away 8.1 is 72.9, which is how much is left at the end of the third hour. And again, we find 10% of 72.9. Divide by 100 times 10, 7.29. This is how much we're going to take away from 72.9 in order to find out how much is left at the end of 4 hours. So 7.29 taken away from 72.9 is equal to 65.6161 milligrams, which is what is left at the end of 4 hours. So that was a long way. Now for the short way. First of all, we need to work out our percentage multiplier. So we want to reduce by 10% each time. This means that we start with 100%. We want to reduce this 100% by 10%. So if we take 10% away, we are left with 90%. Changing that 90% into a decimal is 0.9, and that is our percentage multiplier. So we take the amount that we're starting with, which is 100, we multiply it by our percentage multiplier, and then that percentage multiplier is to the power 4, because we want to know how much is left at the end of 4 hours. Put that into the calculator, and out pops 65.61 milligrams, which I think is an awful lot easier and quicker than the long way. Question 2. The number of people suffering from a virus is 12 million. For each of the next 3 years, the number of people suffering from the virus is expected to be 5% more than the number of the previous year. How many people are expected to be suffering from the virus in 3 years' time? Give your answer in millions. This time we are going to increase the amount that we have by 5% every year. So again, we'll go the long way and then we'll do the short way. So we're going to start by finding 5% of 12. So we're going to divide by 100, multiply by 5, and we get 0.6. We then add that 0.6 onto 12. 12 is what we started with, and we get 12.6. So this is how many people will be suffering from the virus at the end of 1 year. So again, we're going to find 5% of 12.6, divide by 100, multiply by 5, 0.63. Again, we're going to add this on, so 12.6 plus 0.63 gives us 13.23. That is the amount of people in millions who are suffering from the virus at the end of 2 years. Again, 13.23 divided by 100 times 5 is equal to 0.6615. This is what we're going to add on. So 13.23 plus 0.6615 is 13.8915. Now remember, that is million. And that's our final answer. Now for the short way. So the first thing we want to do is find our percentage multiplier. So we're going to start with 100%. And this time we are increasing, so we are adding on by 5% every year. So at the end of 1 year, or at the end of every year, we're going to have 105% of what we originally started with. Change that into a decimal and you get 1.05. That is our percentage multiplier. So we take our 12 million, just going to write 12. We multiply it by our percentage multiplier, 1.05, and then the power is the number or the time that we're waiting for. In this case, it is 3. You put this into the calculator, and lo and behold, we get 13.8915 million. So that's the amount of people who will be suffering from the virus at the end of 3 years. So question 3. In January 1999, it was estimated that the number of monkeys in a colony was 5,000. The number of monkeys is decreasing at the rate of 12% per year. How many monkeys are expected to be in this colony in January 2002? Give your answer to the nearest 10. So we'll start off with the long way. We want to find 12% of 5,000 and take it away. So 5,000 divided by 100 multiplied by 12 equals 600. We're now going to take this away with the amount we started with, which is 5,000. And we get 4,400. So that is what we are left with at January 2000. So we're going to keep repeating this method until we get to January 2002. So we find 12% of 4,400. So we divide by 100, multiply by 12, and we get 528. We're going to take 528 away from 4,400, which gives us 3,872 at January 2001. Again, find 12%, so 3,872 divided by 100 multiplied by 12 is equal to 646.64. We're going to take this away with how much we had. So 3,872 minus 646.64 is equal to 3,407.36 in January 2002. We've been asked to round this number to the nearest 10. So there's our tens there. So we'll look at the number next to it to decide whether we are going to go up or stay the same. In this case, because we have a 7, that means the 0 has to go up. So our final answer at January 2002 is 3,410 monkeys. So same question but the quick way. So first of all, we need to find our percentage multiplier. We are told that it's decreasing, so we're going to take our 100% and we are going to minus 12%. So we are left with 88%. So at the end of each year, we will end up with 88% of the original amount that we started with at the beginning of the year. So change that into a decimal, we get 0.88. That is our multiplier. So we take the amount we started with, 5,000, we multiply it by our multiplier, 0.88, and we put the power to the amount of time we want. In this case, it is 3 years. Put it into the calculator and it spits out 3407.36. We have to round to the nearest 10. So there's our tens. That's what decides. So as we have a 7, we have to go up. So our final answer to the nearest 10 is 3410. So 3,400 monkeys. And that's to the nearest 10. So question 4, bacteria in a test tube increase at the rate of 0.6% per hour. At 12 noon there are 5,000 bacteria. At 3 p.m. how many bacteria will be present? Give your answer to 3 significant figures. So long method first, 5,000 divided by 100 multiplied by 0.6 is equal to 30. So to find out how much we have at the end of 1 hour, we do 5,000 plus 30 is equal to 5,030. And that is how much we have at 1 p.m. Same again for the second hour. 5,030 divide 100 multiplied by 0.6, 30.18. So we add this on to what we started with. So 5,030 plus 30.18 is 5,060.18. That's how much bacteria we have at 2 p.m. Same again, 5,060.18 divided by 100 multiplied by 0.6 is equal to 30.36108. Add this on to what we started with. So 5,060.18 plus 30.36108 is equal to 5,090.54108. That is how much bacteria we have at 3 p.m. Now we have been asked to round this to 3 significant figures. So if we start counting, there is our first significant figure, second significant figure, third significant figure. So this means that we have to round this to the nearest 10. So we are rounding to the 9, which is our third significant figure. So we'll look at what's next door. We have a 0. That means the 9 doesn't change. So our final answer to 3 significant figures is 5,090. Okay, so let's do this a quick way. So we need to increase by 0.6% at the end of every hour. So that means we have 100% plus 0.6% is equal to 100.6%, which is equal to 1.006. So that's our percentage multiplier. So we take the amount we start with, which is 5,000, we multiply it by 1.006, and our time scale is 3, so that's our power. Plonk that into the calculator, and it comes out with 5,090.54108. Now we've been told to round to 3 significant figures. So we start counting as soon as we hit a number that is not 0. So 1, 2, 3, that's my third significant figure. So I'm going to round to the nearest 10. So rounded to the nearest 10, we get 5,090 bacteria at 3 p.m. So question 5, Paul bought a car last year. It has lost 12.5% of its value since then. It is now valued at 10,500. How much did Paul pay for his car? So over the course of the year, Paul's car lost 12.5%. So he started, when he bought it new, it was 100%. It lost the 12.5%. So at the end of the 1 year, its value is 87.5% of the original. So the 10,500 is equal to 87.5%. So we need to work this backwards and get back to the 100%. So we take the 10,500, we divide it by 87.5 to find 1%, and then we multiply 100 by 100 to get back to our 100%. So Paul's car was originally worth, when he bought it, £12,000. Okay, question 6. Marmalade is in special offer. Each jar is on special offer contains 12.5% more than the standard jar. A jar in special offer contains 450 grams of marmalade. How much does the standard jar contain? So the jars on special offer are equal to 112% compared to the standard jar. It's got 12.5% more. So the 450 grams is equal to 112% of the original. So we want to get back to the original price. So we take 450 and we divide it by 112.5. That's going to take us back to 1%. And then we are going to multiply by 100 to take us back to 100%, which is 400. So our standard jar is equal to 400 grams. So question 7. One video costs £13.50. On special offer is a pack of 8 videos costing £104. So A, how much is saved by buying the pack? So first of all, we're going to find out the cost of the 8 single videos. So that would be 8 times £13.50, which is equal to £108. So then to find how much is saved, we take the difference between the two prices. So we do 108 minus 104, and the saving is £4 if you take the pack. So that's question A answered. So question B, express the saving as a percentage of the cost of the 8 single videos. So we take our saving, which is 4, and we put it over the cost of the 8 single videos, which is 108. We then multiply this fraction by 100, which gets us 3.7037 percent. Now, play safe. If you're not told otherwise, round to 2 decimal places. So there's my second decimal place. That's what's going to decide whether we stay or go up. So as it's a 3, the 0 is going to stay as is. So 3.70% is our final answer for B. Question 8. John buys a football programme for £1.60 and sells it for £2. Calculate his percentage profit. So profit is equal to the selling price minus the cost price. So in this case, our profit is going to be equal to 2 minus 1.6, which is equal to 0.4, which is equal to 40p. So to find the percentage profit, we're looking for the profit over the cost, which is equal to 0.4 over 1.6. Now, if this turns up in a non-calculator, you need to be able to simplify that fraction. In this case, 0.4 over 1.6 will simplify to 1/4. And as we all know, a quarter is equal to 25%. So the percentage profit of the cost price is 25%. So question 9, the average mass of a grain of pollen is 2.3 times 10 to the minus 5 grams. Write this number out in full. Now notice the negative power. This means that we are looking for a small number. It is less than 0. So starting with 2.3, it means we have got to move this decimal point 5 places, and we are going to the left. So 1, 2, 3, 4, 5. That's where it ends up. So anything that's got a blank, we're going to put a 0 in. And of course, we need a 0 before our decimal point. So tidied up, this is going to read 0.1, 2, 3, 4 zeros, and then 2, 3 grams. So question 10, the planet Pluto is approximately 7,364 million kilometres from the Sun. Write this number in scientific notation. So start by writing it out in full. 7,364 million, that means we need to put 6 zeros on the end. Now we want a number that is more than 1 but less than 10. So the decimal point is going to have to go in here. So how far did it move to get to there? It went 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So our final answer is 7.364 times 10 to the power 9 kilometres. Do not round. Do not miss any numbers out. Question 11. A ship is transporting 2,800 cars. Each car is worth £20,000. A. What is the total value of all the cars? So we want to multiply 2,800 by 20,000. Now if this turns up in non-calculator, the easy way to do it is to double the 2,800, which gets you 5,600, and then shove 4 zeros on the end. So 5,600 and 4 more zeros in the end. 1, 2, 3, 4. So our total value of all the cars is 56 million. So again, to write this in scientific notation for part B, we want a number that is more than 1 but less than 10. So our decimal point is going to go in between the 5 and the 6. So how far did it move to get there? 1, 2, 3, 4, 5, 6, 7. So our final answer is, the final answer is 5.7 times 10 to the power 7 pounds.